From mysterious spinning stars to cosmic lighthouses, pulsars have captivated astronomers since their discovery in 1967. These remarkable stellar remnants pack the mass of our Sun into something the size of Manhattan, spinning hundreds of times per second. Back in 1967, graduate student Jocelyn Bell Burnell was analyzing data from a new radio telescope when she noticed something odd, a signal that kept appearing and disappearing with perfect timing. At first, the team thought it might be interference from Earth or even signals from aliens. They nicknamed the source LGM-1 for Little Green Men. But as Bell Burnell kept observing, she found more of these regular pulses coming from different parts of the sky. This ruled out aliens and led to one of astronomy's biggest discoveries: pulsars. These cosmic lighthouses were actually rapidly spinning neutron stars, sending beams of radiation into space like a celestial lighthouse. While Bell Burnell's supervisor Anthony Hewish won the Nobel Prize for this discovery, many argue she deserved equal credit for her careful detective work. Let's talk about what makes pulsars such amazing cosmic clocks. These spinning stars are so reliable, they put even our best atomic clocks to shame. Some pulsars rotate hundreds of times each second, and they keep this pace with amazing accuracy. Think about this. After a year of spinning, a typical pulsar might only be off by a fraction of a second. This precision makes pulsars incredibly useful tools for astronomers. Scientists use them to test Einstein's theories, measure distances in space, and even create a cosmic GPS system. The secret behind this perfect timing lies in the pulsar's physics. They're so dense and spin so smoothly that almost nothing can disturb their rotation. It's like a cosmic figure skater who never gets tired. When astronomers discovered two pulsars dancing around each other in space, they hit the scientific jackpot. These binary pulsar systems work like a perfect laboratory in space. As the two stars orbit each other, they create tiny changes in their pulses that we can measure from Earth. In 1974, astronomers Hulse and Taylor found the first binary pulsar, and it showed something amazing. The stars were slowly moving closer together, losing energy exactly as Einstein's theory predicted. This cosmic dance was the first solid proof that gravitational waves exist, decades before we could detect them directly. The discovery was so important that Hulse and Taylor won the Nobel Prize in 1993. These spinning pairs continue to help us test our theories about gravity and space. Now, let's talk about the speed demons of space, millisecond pulsars. These cosmic spinners are the fastest rotating natural objects we've ever found. Imagine a star that spins faster than your kitchen blender, up to 716 times every second. That's so fast that if these pulsars were just a bit bigger, they'd tear themselves apart. These super speedsters got their incredible spin from stealing material from nearby stars over millions of years. As this stolen material falls onto the pulsar, it works like a cosmic spinning top, making the pulsar spin faster and faster. These millisecond pulsars are so precise in their rotation that they're like nature's finest watches, helping us track time across the universe and spot tiny changes in space itself. The real magic happens inside these cosmic lighthouses. Pulsars create their powerful beams through an amazing mix of super strong magnetic fields and fast rotation. Picture a magnet 1 trillion times stronger than Earth's magnetic field, spinning hundreds of times per second. This creates huge electric fields that rip particles from the pulsar's surface and shoot them into space at nearly the speed of light. These particles spiral around magnetic field lines, creating beams of radio waves and other radiation. Think of it like a cosmic sprinkler system, spraying energy into space as it spins. The beams shoot out from the pulsar's magnetic poles, which usually aren't lined up with its spin axis. This offset is why we see the pulses, like a lighthouse beam sweeping past Earth. Pulsars aren't just fascinating space objects, they're also natural navigation beacons for space travel. Just like GPS uses satellite signals to pinpoint locations on Earth, astronomers can use pulsar signals to figure out exactly where a spacecraft is in our solar system. Each pulsar has its own unique timing pattern, like a cosmic fingerprint. By measuring signals from several pulsars, spacecraft can calculate their position with amazing accuracy. NASA has already tested this technology with their NICER telescope on the International Space Station. Imagine future spacecraft using pulsars like sailors once used the stars, but with much better precision. This pulsar navigation system could work even in the deepest parts of space, far beyond where regular GPS signals can reach. It's like having a set of perfect lighthouses scattered throughout the galaxy. Sometimes these cosmic clocks do something unexpected. They hiccup. These glitches happen when a pulsar suddenly speeds up its rotation without warning. It's like a figure skater suddenly spinning faster without any obvious push. These mysterious speed-ups have left astronomers scratching their heads for years. The leading theory suggests these glitches happen when the star's super-dense inner fluid suddenly shifts, like an egg's yolk sloshing around inside its shell. These events give scientists rare glimpses into what's happening inside these mysterious stars. By studying these glitches, astronomers are slowly piecing together how pulsars work on the inside. Every new glitch adds another piece to this cosmic puzzle, helping us understand these fascinating stellar objects better. Pulsars are helping us detect ripples in space itself, gravitational waves. Astronomers carefully track the timing of pulses from many pulsars spread across our galaxy, forming what we call a pulsar timing array. When massive events like colliding black holes send gravitational waves through space, these waves slightly change when pulsar signals reach Earth. It's like watching ripples move through a cosmic pond. By monitoring dozens of pulsars at once, scientists can spot these tiny changes and track gravitational waves that are too slow for other detectors to find. This technique is helping us spot supermassive black holes merging in distant galaxies, and could even reveal traces from the early universe. Pulsars are turning out to be some of our best tools for understanding gravity itself. Let's explore magnetars, the most powerful magnets in the universe. These rare pulsars have magnetic fields so strong they could wipe your credit card clean from halfway to the moon. When a regular pulsar just isn't extreme enough, nature gives us these cosmic powerhouses. Their magnetic fields are about 1,000,000,000 times stronger than Earth's, making them incredibly dangerous and fascinating. These fields are so powerful they can actually affect the behavior of atoms and bend light. When magnetars have starquakes, they release more energy in a second than our sun does in thousands of years. Scientists have only found about 30 magnetars in our galaxy, making them the rarest type of pulsar. They're basically pulsars turned up to 11, pushing the limits of what we thought was possible in nature. Pulsars might help us crack one of space's biggest mysteries, dark matter. These spinning stars are so precise that even tiny disturbances in their signals could reveal dark matter particles passing nearby. Think of pulsars as super-sensitive scales in space. If dark matter particles float through their beams or affect their spinning, we could spot these changes from Earth. Scientists are watching groups of pulsars across our galaxy, looking for unusual patterns that might point to dark matter's presence. Some researchers think dark matter might collect around pulsars, making them perfect places to look for this invisible stuff. It's like using these cosmic lighthouses to spot shadows we can't see directly. While we haven't found dark matter yet, pulsars might just help us solve this cosmic puzzle. Thanks for joining us on this incredible journey through the world of pulsars. We've only scratched the surface of these amazing cosmic objects. If you enjoyed learning about space's perfect timekeepers, hit like, subscribe, and share with fellow space enthusiasts.